Hello, everybody, and welcome to our webinar today on Linux and Unix viruses, malware, the things we're seeing out there in the industry, and ways that you can help to protect yourself. We will have time for questions at the end of the session today, so feel free to go ahead and put those into the question pane, and we'll be able to answer those for you at the end. My name is Bob Erdman. I am the Senior Security Product Manager here at Help Systems in our Cyber Threat Solutions division. I've had a lot of experience over the years working with different industries and applications on Linux and Windows and Unix system compliances, any number of different regulations. One common theme on almost all of those is the need for protecting your critical systems, of course, to make sure that you are not going to be infected with malware and viruses and one of those breaches that we hate to hear about in the news every day. So we're going to talk a little bit about that today, some ways that we can protect ourselves better, some things that we're seeing in the industry, some of the trends out there in the field, and just make sure everybody has a good idea of what's going on out there these days. So we'll go over the current threat landscape, some of the malware mixes that we're seeing today, why we think it's pretty important to have virus protection on your Linux and Unix systems, some ways that you can implement those protections, and take a quick look at some of the things that we can help out with in that respect, of course, with our PowerTech antivirus solution, and definitely take some time for questions. So what are some of the things that we're seeing out there in the field today? Number one, and you've probably seen it every day almost in the news lately, ransomware is still on the rise. And ransomware has been around for a really long time. It's not even always used just primarily for ransom. Sometimes it's used to, get IT looking somewhere else while people are trying to do a different breach throughout the enterprise. And it really got pretty big back in 2015, 2016 area, where people were starting to deploy ransomware either individually or as a decoy. And some of the high profile examples were things like Sandworm, which was a big Trojan espionage group that used to go out and run primarily on Linux computers. And it would essentially make them unusable by encrypting everything in the operating system file. And then once it, of course, finished that encryption, it would give you a ransom demand. At the time, it was about $250,000. That's still a pretty big ransom out there. And as always, paying the ransom wouldn't necessarily help you because the keys didn't actually work to decrypt your files. You would basically just give them money. The keys weren't actually saved on the system or up on the command and control CNC servers. And it was used in quite a number of attacks, using attacks against shipping, using attacks in the financial sectors, and sometimes just used along with denial of service as a decoy so you could sow that confusion amongst IT. Ransomware is so common, especially even these days. IT may not even be surprised to have ransomware pop up. They're going to go deal with the ransomware thing, and while they're over dealing with ransomware, somebody else is over here trying to break into a critical system while they're not really paying so close of attention. So ransomware is really getting to be a big problem. Some of those recent demands that we've seen where they're trying to ask for upwards of $3, $4, $5 million are really getting kind of crazy, and people are starting to not pay it so much. They're trying to come back from backups. That is a good scheme sometimes. It doesn't always work, of course. Sometimes the backups are also encrypted. The sneaky guys will actually let that ransomware run for a while, make sure that it's infecting those backups as they're stored off. So when they flip that switch, you can't get to your backups either. And we're seeing some of that also coming into play with the big trend around cyber insurance, where the demands are trying to come from these vendors to fall just under that cyber insurance payment. They figure it's going to be easy to get you to give them money if your insurance carrier is going to be the one writing the check. So let's try and ask for just enough. But we have seen some pretty big, demands out there. I think one of the biggest was just over $1 million that we know of today, at least that came up publicly. That was paid for Linux systems actually over in Korea. A big MSP was compromised. All of their client systems got compromised, and they wrote a really hefty check to get access back. But writing that check, of course, doesn't always work. Sometimes you get some of the files back. Sometimes you can get all of them. Sometimes you get none of them back, and they're just going to collect that money. So we really need to be on the watch for this ransomware. Some of the new ones that have recently come out Lilu is a new one, Lilocked, sometimes referred to. It's relatively new. That is, again, specifically targeting Linux servers. Right now, we think it's targeted about 7,000 systems that have been indexed. And they're able to be indexed because that ransomware strain is actually not taking the systems down, at least not yet. It's really trying to block specific file types like HTML, PHP, image files. It's really hitting websites right now, locking those out, and then, of course, given the ransom demand. And it's a fairly low demand, actually, right now. It's only, under $1,000. Of course, that could all change. Don't really know why it's not being more destructive. If they're just nice, they didn't know what they're doing, trying a different tact. Or it could be that they're going to collect what they can right now, and then at some later point, of course, flip a bigger switch. Since they are having command and control ability with these systems, of course, that also opens up what else might they be getting into in the background. If you're dealing with this up in the front and they're in these systems, that gives them that foothold to pivot and get into the rest of the network, of course. And at any point, they could flip that switch and take down all of these systems that they currently are leaving up, but they have taken over some of the files. Crypto miners are also still fairly popular. It really depends a little bit about the price. Price of Monero is going back up, starting to see more crypto mining again. So it's a bit of a play on the money. Are they going to get more money on ransomware? Are they going to get more money on crypto mining? There is another new variant also out there targeting Linux specifically in the crypto mining realm, commonly referred to as SkidMap. It's being used to mine cryptocurrency, and it's pretty sneaky. Once it gets into a system, it's generally coming in through crontab. So everybody should be, of course, thinking about best practices around securing your crontab files. That, of course, is limiting who can access those files, making sure that you have passed everything executing in there so that it is not executing world writable things, root permission things. You're not allowing people to put things in temporary folders, controlling who can insert into that, of course. Checking those file monitors. But once it's in, it's dropping a whole lot of binaries on the backside, along with the backdoor access. It's actually replacing the pamunix.so file, which is your pluggable authentication. So it's blocking out that file with a file of their own, which gives them backdoor credential access to all these systems. So again, we're also having to deal with, if they've gotten this far, where are they pivoting to within the network to do other things as well while we're dealing with this. It does make some modifications to the Linux kernel, and it's really sneaky because it's using things to hide its CPU statistics and usage. So a lot of times with the cryptocurrency miners, an easy way to detect it if you're not seeing the actual processes is to see that spike in system usage. What kind of resources are they burning on my servers? And if they're hiding those statistics, that takes one of those primary initial indicators away from us being able to see that something has changed on our system. So again, we need to be watching, good best practice things on those systems, taking care of our cron tabs, of course. Watching critical system files is another high runner on that best practice list. Do I know when the hash file value changes on some of my critical system files? If I see pam.unix replaced, am I getting a notification because that binary has just changed on my servers? If I see my kernel replaced, am I getting a notification because that binary just changed on my server? So different things like that are other ways that we can help protect ourselves. But the cryptocurrency mining, like we said, it goes up and down. It's starting to spike up again right now, where we're having to watch those things again. But people definitely aren't targeting just Windows. They're also targeting Linux as well on all of these things. And that huge growth industry many times is targeted at those LAMP servers. So running Linux as the open source web server, and then generally Apache as the web front end, MySQL, and then either PHP or Perl or sometimes Python as that backside scripting engine. And there's three big strategies they like to employ there. The first is distributed mining, where they're really using a mass of like malware infected computers or botnets to do that coin mining. A lot of times that is hosted on websites, either directly on the web servers, or it's done as a drive-by. So somebody visits your website and they are infected on their end actually with the malicious binaries that they've placed out there. So they can keep that usage down but spread it across a large amount of systems and try and hide that. And of course, then they also secondarily like to attack those targeted corporate and organizational networks because they've got big systems. Big systems being big CPU. Big CPU means bigger profits for them. And then finally, of course, is up in the cloud services where they can really get some high-powered mining. And this has that really big financial impact where you may not see it until your bill comes in at the end of the month that something drastic has changed on your systems. So if they can get access to direct server images, get logged into a system that's open the way it shouldn't be up on the internet, or more dangerously, if they can get access to a management console. And those are the specifically really dangerous ones. And we've seen that happen more than once, where somebody spins up a management console. They're protecting their cloud servers pretty well. They've got those locked down. They're doing the proper DevOps things. But the management console used back in their environment to access that dashboard has a vulnerability and it's left open. If somebody can get into that system, they now control everything in your cloud. It has been used even maliciously in some of those attempts to just knock down everything. Somebody just takes down and deletes all your cloud servers, and now you're out of business. That has happened as well. So recently we've seen some of these strains also come in through SSH vulnerabilities. So if they can find an open SSH portal and they can break into that, then they can, of course, infect those systems. Some of these guys are getting pretty smart even about how they're looking for other malware. So as soon as they get into a system, the first thing that they do is look for somebody else's coin mining system, because if they got in, somebody else might have too. Knock that system down, take over that for themselves, and now they do that reinfect sequence on their own, where now they're in control of that system. Another large vector where we're seeing these infections coming out, probably the biggest in overall numbers, is through phishing attacks. So somebody is sending a blanket phishing message to your end users, trying to get them to click on something that they shouldn't have and provide back data. Or even better, if they can, trying to get them to put in some kind of credentials and provide credentials back that they can use to those systems. And there's a number of different ways they can go about this. There is a wealth of information out on the internet, open source intelligence, as everybody likes to call it. So we can go out, and once we've decided who we want to target, that's always, of course, the first piece of our reconnaissance is, who am I going to go after? Sometimes we'll just send a big blanket en masse email, hope to see where it gets clicked from, and then we'll go off after that. But a lot of times it's much more targeted. I'm going to go after help systems. I'm going to go out to LinkedIn and look for employees. I'm going to go out to customer lists and look for customers, look through case studies, gather all of that back-end intel so that I can craft my messages on what I want to do. And it can be really, really deceptive when people do that. So if I want to say maybe try and get somebody to click on something or get some kind of credentials, maybe I'm going to go out and target finance and accounting. So I'm going to make my message look like, hey, I've got an invoice problem. I want you to help me get this resolved so I can pay you. Try and send that in at a busy time, so end of the month, end of the quarter. Try and get someone to click on that attachment. And once that attachment runs, I now have a malware foothold into the environment. I can turn and pivot from there to the backend servers and start to do my dirty work on the backside. So it's very important that we train our user base on how to recognize different phishing attacks. So implementing some standard processes and procedures where we can step those users through phishing exercises internally, see how well they're doing. So we want to start them out, with something fairly fairly recognizable, get them used to the idea that this is not adversarial with them. We don't want them to be afraid of IT. We don't want them to be worried about doing something by mistake. We want them to learn. And as they get better with these things, then we want to step up the attacks, make them harder to realize, make them harder to understand, because that human interface is sometimes the weakest link in the chain. Even if we have great protections and patches on all of our systems, if we can get somebody to click on an attachment, now we've got that foothold into the enterprise anyways. A lot of times we're also seeing malware originally built for Internet of Things, migrating to Linux backend server systems. Of course, many of those Internet of Things devices are running some flavor of a micro Linux distribution. So once it's been ported there, it's fairly easy to port that across. So as people are licensing those big powers of botnets, those attacks are getting pretty frequent now. And we don't see it in the news as often as we used to a few years ago, where they'd have that big NBC News story every other night saying, hey, this huge new botnet just got discovered. But they're still out there and they're still pretty common. So many times, like those open source web hosting software stacks are being exploited. Either they're doing denial of service attacks, or they're being used to crack passwords, break into those vulnerable Linux servers. And then once people can brute force their way in through SSH logins or something else, then they can, of course, install their malware. And that's where, again, it's really important that we're protecting our entry points, our front doors. Do we have controls on our logins? We have worked with individuals that have called up after they've had a breach type problem where they had an open terminal login to the internet by accident. They thought they needed it for a vendor access or some such thing. And they also had no controls on the backside limiting login attempts. So you can sit there and brute force and brute force and brute force until you finally can get in. We had one site actually go down because their failed logins log got so big it took down the whole root partition of their server and crashed it, and that's how they realized they had a problem. So it's really important that we're watching those different things. If you don't need outside access, you shouldn't be allowing outside access to those prompts. If you are using those prompts, you should be watching failed login attempts, locking out users, slowing down that login process with bigger and bigger delays as it gets a reattempt in. All those things help mitigate those brute force type attacks, and of course then patching our SSH programs so that we don't have openings like shell shock and other things that people can use to try and break into our systems. And finally, one of the biggest things that we see is how long it takes for people to discover that they've actually been breached. Sometimes it's not even you that discovers, it's somebody that you work with or law enforcement saying, hey, we're seeing issues coming from systems on your end of the software. We find average, it is going down. It used to be a couple hundred days. Now it's down more, to 100 or so days to discover that a breach has happened. That's still many months of somebody poking around inside of a system. So having ways to detect when there are malicious actors inside of your environment. How do I know that somebody is in there living off the land maybe? Maybe they haven't installed a binary that I can detect really easily, and instead they're living on shell scripts, Perl, and other scripting languages where I'm running things underneath, but I'm not actually doing things like that. So the longer it takes to discover these breaches, of course, in general, the more costly it is then to remediate. The cost of a breach studies when they come out are generally in the millions of dollars on average. That's, of course, not everybody. It's some really big breaches, some really small breaches, and a whole lot in the middle. But the longer that thing sits out there, the more chance people have to lose records, lose credit card data, lose critical information that's intellectual property like system diagrams and different things. There's any number of different crown jewels that somebody might be coming into a system to try and steal. And it really depends on the motivations of that backside actor. Are they just out for revenge and they want to take your company down? Or are they out there to steal intellectual property, or maybe just try and make money by stealing a customer information list where they can go out and target those customers? So there's lots of different types of malware that we see out there on the Linux and Unix side. Some of the general ones, and this is just kind of a bit of a more general list, plain old executables. So somebody wrote a program and wrote it for Linux. That happens all the time. Sometimes it's Windows-based at first and it gets ported over. Other times it's like that skid map and it's directly written for Linux-type solutions. Much more often now, we'll see those downloaders in that second thing. So somebody compromises you, and then they're going to try and interrogate what they compromised, and then they're going to try and put the right type of malware on those systems. So those guys that specialize in that initial attack vector, if I launch onto a Linux system, I'm going to load Linux malware. If I launch onto Windows, I'm going to load Windows. And the scripts have gotten really smart about looking at what is there and then deploying the proper things on the backside. And then once they have that information, they can then hand those off to the resellers that are going to categorize those systems, put them together into groups, and then they're going to pass them off to the correct threat actor groups that like to work with those type of solutions. Another quite common one is distributed denial of service attacks. Backdoor Tsunami, Linux Flood, any number of different ones that are out there. where we are trying to use the harnessed processing power of thousands and thousands of systems to direct attacks at individuals or companies that we don't like, either just maliciously, sometimes for fun, sometimes because we want to use it to hide other things that we're trying to do in that environment. So if we go out to your e-commerce site, launch a huge DDoS attack to take that down, you know, how much money per minute of downtime is being lost there because people can't place an order. And while everybody's busy working on that, somebody else is over in the other side of the corner trying to get in and steal some kind of backend information. And then, of course, there is just the general shell scripts, Perl scripts, Python scripts, maliciously targeted programs going after those Linux and Unix solutions. There's also many other types as well. These are just some of the more common ones that we see out there in the field. Some other recent examples, beyond the couple that I mentioned. Mariah, of course, it was the first big botnet lately that exploited a lot of flaws. It keeps reincarnating itself because that code did go out to open source fairly easily, where people have been modifying it, making it better, allowing it to infect lots of other additional systems. One of the big targets lately has been Hadoop. Big data clusters, of course, have big CPU horsepower and memory behind them. It gives you a lot of power. We can get access to those. Winty, again, working as a backdoor agent infecting hosts, granting attackers access to systems. There was a large pharmaceutical hit by that recently. We think it came from a state actor over in the east. Everybody can probably kind of guess which ones those would be. Hidden WASP, another fairly common one, really going out and trying to achieve targeted remote control. A lot of times, currently, they're not just going after individual corporations or individual users. They're targeting security solution providers or MSSPs. So if I can compromise the command and dashboard area of a service provider, now I not only have access to their systems, I probably have access to every one of their customer systems as well, and it's a lot bigger bang for the buck for me. So if I can make that targeted attack at the right places, then I can get access to a lot more things behind the scenes. Evil Gnome's another new one, really designed to spy on people and being used for some of those more targeted attacks. If you've heard of some of those in the field, there's lots of ways people are doing those more individualized attacks today. Either spear phishing certain executives in a company, trying to get data off of people's phones or people's PCs to be used to blackmail them into making payments, or just to try and keylog off of their systems and steal access then to further systems within the network. So there's lots of different ways, lots of different tactics that people are using these days. There's also lots of things in the underground marketplace and the dark web that make it really simple for people to do this. That's probably the scariest thing, is how easy a lot of this is these days. You can buy ransomware toolkits, you can hire DDoS attacks, you can pay for documents, utility bills, passports, buy banking Trojans and credit card numbers. All these different things are out there and accessible if you go out on the dark web and look for them. We always, of course, see in the news where some security service in combination with some security research vendor has announced they've taken down this big, huge botnet. Global span has dropped by 80%. Everybody's happy. 2 weeks later, everything's right back where it used to be. They're really good at re-enabling things once they've been taken down. If they can't get to an actual individual and take them offline, and all they can do is take down the technology, a lot of times that technology comes back around. There's many different techniques for doing that. A fairly common one is when they create these big command and control networks, they'll put in some back doors to re-enable themselves. So as those end systems are reaching out for control, eventually that control goes away because FBI just took down a big botnet. Those systems know what to do to get it back, and they'll go out to some general site many times. Like maybe they'll go to CNN.com at 2 a.m. on September 30th, and they'll pull the top headline, and they'll calculate a whole bunch of new domains based upon that headline with an algorithm, and they'll just start trying every one of those. And the threat actor on the backside will do the exact same thing. So they're going to go out, they're going to do that, and they're going to register a few of those domains based upon that calculation that they're done. And as those end systems are doing their chat, and they can't find anything, eventually they're going to hit one of those new domains that the threat actor has registered. Everything comes right back up online. So that's why you see a lot of that ebb and flow inside of these things. If we can't actually get to those threat actors, and many times it's pretty tough because they know where there's no extradition treaties, they know where they're treated pretty favorably. And as long as they can re-enable those services again, they can kind of restart those networks. So it gets to be a pretty large problem out there, and we've all got to do a better job of protecting ourselves and protecting our environments for these things. So we feel it is really important to not only protect your Windows systems, your desktops, what everybody generally is doing anyways, but also think about your backend servers, your backend systems. A lot of times that's where the most critical data is in your environment. That's where the biggest horsepower is in your environment, because no OS is really immune. There's plenty of things that are written for Linux. There's plenty of things that are written for Unix. It's very easy to go out and infect a mainframe even and to run ransomware attacks. Think about a large system. What are some of the best things that it's built for? Encryption. So once they get that foothold, one of the fastest things they can do is ransomware that system because it's great at encrypting everything. And a lot of those servers have great, beautiful, high-end synchronous backups for every transaction. So as soon as I encrypt it over here, it's just encrypted over on the DR site. So like we talked about a little bit earlier, the largest that we know of to date that's been paid was a little over $1 million in Bitcoin to get those Linux systems back online. There was recently, I heard a demand for about $5 million based on one of those governmental breaches. They actually refused to pay it because they just didn't have the money. Insurance wasn't going to cover it, and they just went offline and been recovering from backups to get those systems back. But Linux and Unix systems can also definitely spread malware. So maybe I am not able to be compromised by WannaCry. It's not going to execute on my Linux server, but I can certainly distribute it to every Windows machine that connects to my Linux server and compromise them. So as the end systems get cleaned up, they connect back up to my backend CRM or ERP or whatever that system is. They just get reinfected again until we clean up on the back end. There's also a lot of regulatory mandates that require you to have malware protection on different parts of your environment. PCI is a big one. They actually say in their requirements that all servers that are in scope, which means anywhere that you're storing and touching that critical credit card data from, should have malware protection on those systems. So we want to make sure that we're always looking at all the different places in our environment where we need to be worried about being vulnerable. Every time one of these secured systems faces an attack, new vulnerabilities are discovered, the malware keeps changing. And if we're not always updating those systems and paying attention, of course, we can be exploited and run into those types of compliance requirements. Health information, PII, EPHI, all those different things are very important as well. We want to watch HIPPA and high-tech rules, make sure that we're protecting the integrity of our systems, not running malware, not running compromised binaries, not running things that can exfiltrate data from our solutions. There have been some very big HIPAA fines reached with settlements based on breaches. A few years ago, there was a fine upwards of $100 million levered against a very large provider because of the disclosure of critical PHI data that had been exfiltrated from the systems after a breach and a compromise. So there's lots of reasons, again, that we want to be protecting those systems. And even some of our business requirements like Graham Leachy, making sure that we're protecting against anticipated threats and hazards. Again, we should be anticipating that somebody is going to be trying to breach our backend servers and our backend solutions and protect ourselves against that. So we want to be really good about that. And it's not just that you have sloppy patching and things. Even well-patched, well-managed systems, of course, like we said, can be carriers of infections. And maybe they're not going to run on Linux themselves, but they're Windows malware that's hiding on Linux. If you're using Samba, CIFS type shares, you can pass those files around, and those variants can then be spread throughout the network. And sometimes we'll try and use Windows solutions to scan for some of those. So I'm going to try and scan on my mounted file systems. Those can have their own sets of problems. Windows doesn't always understand what the Linux file systems are like, or you're scanning from many different points on your network because everybody's seeing the same share file, or different things like that. So we want to get back to our back-end targets, and we want to make sure that we're scanning systems from the back end. We don't want to be Typhoid Mary. I can't be infected, but I'm infecting everybody else around me because I've been compromised as we move along and do things like that. So there are lots of ways to protect your environments. We've mentioned a few, making sure that we're using good best practice controls on our systems, monitoring for changes in our systems, and also, of course, running malware and antivirus protection on our systems. So we like to have native protection on those systems, make sure that we can do it without performance issues, use heuristics analysis, other technologies, even use, if you need to, on-the-wire technologies where we're watching command and control communications. PowerTech antivirus is a great solution for that, we think. It gives you not only command line interface on those endpoint systems, but more importantly for these big enterprise environments, centralized control and dashboarding where you can fully manage and monitor those solutions from a single entry point, either from a Windows system, a Linux system, or even from a mobile phone where you can have full access to that environment, instant notifications, being able to send things out through SIM and syslogs, being able to send alerts up to the SOC dashboard screens up on the wall, as well as alerts directly off to your security analysts in your environments. And we do have, a lot of people using that solution out there in the field. It has a lot of great things for enterprise type deployments. So ways to limit resource usage so that you're not taking down your front end users because of the back end demands of your malware systems. Of course, we want to make sure that we can include and exclude directories as we need, especially on maybe big end database systems. Generally, you're going to want to exclude those database DBF type files until maintenance times because they're changing so often. Making sure that we can alert instantly when we see things happening. So I want to make sure that I can send things out to my SIM. I want to be able to send emails off to my analysts. I want to be able to notify up on my phone and see those different things that are going on inside of my environments, and make sure that any updates are really flexible and easy to use. That's always a big problem with a lot of these back-end solutions is how do I keep updating and making sure that I'm staying current with the latest program fixes, the latest malware things that are happening out there, being able to do that internally so I don't have to have my systems reaching out. One thing that we also see a lot is people just checking the box. I'm going to run open source, and it fills the box on my PCI report. Open source isn't always free because you have to manage a lot of it yourself, and it doesn't always have really great detection rates either. We make sure as an enterprise vendor that we are building our solutions internally to enterprise grade. We are using third-party testing firms that go out and make sure that the systems work as designed and that they work better than the open source competition that is out there. We think that's a great selling point on our side to make sure that, we give a really better grade protection and a better grade administration that a lot of these other solutions do. Help systems in general, if you aren't very familiar with us, we are a global company. We have three main pillars in our solution sets. Workload automation, so being able to take your business processes, your network monitoring, your other performance type events, and centralize and automate a lot of that workload to help with your IT and your deliverables. Information and analytics, as well as a large list of different security solutions, everything from penetration testing, red team type software, to risk assessments, SIM and identity and access governance and management, as well as a very well-skilled services firm that can do pen testing engagements, that can do risk assessment for you, or even help you with remediation and cleanup work on those systems to make sure that you're sitting at the best protection possible. So we'd like to open it up for some questions. So if you do have any questions, please feel free to type those in, and we'll make sure that we can answer those for you. We want to make sure that everybody's taking the time to look at these threats to the solution seriously, make sure that we're not just letting the system stay in the background and forgetting about them. Linux definitely isn't immune to malware out there. We do have free trials available where you can download a fully running version of the software and put it in your own deployments for a month and test it out. So we'll take a look for questions now coming in from all of you out there listening to us. One of the ones that just came in, I see, is what platforms does the management console run on? So that management console can run on either Linux systems themselves, or it can also run on Windows. It can even run on Linux on Power. I didn't really speak to that earlier, but this not only works on x86 Linux, It also works on Unix type systems like AIX, and it also works on Linux on Power type systems. So if you're running maybe that SUSE on Power for your SAP HANA databases, or you're running Red Hat on Power, it can also deploy natively on Power. So the solution is actually built individually for each of those architectures. So you'll get an RPM that's based on the back-end systems that you're trying to protect. We also had a question if there was extra cost for that management. That management is actually included with the system. So you can choose to run backend only, where you're running at the terminal type interface, but we would highly encourage you to take a look at the management console because that is a free add-on to the system. So you can light that up and not only see reporting back of what's happening on your endpoints, but even deploy out to those. So if you're in a larger environment and you don't want to have to manually touch all of those systems at the keyboard, you can deploy the solution right from the management console and then work with those systems as they come back and forth. Are Windows viruses detected the same as Linux? Yes. So when we are doing malware activities on the system, we are not only looking for Linux-based malware, and there's thousands and thousands of those families that are being detected, also Windows malware at the same time. So if you do have something get compromised down, we will still detect it and identify it. So if maybe a WannaCry infected executable comes down to a Linux file store, we'll still be able to see that and launch that to you in your reporting as WannaCry and things like that. And then somebody asked about real-time scanning, if we can do real-time scanning, or is it only done through command line or cron? So we have a couple different options for scanning, and most people use a mix of them. We have a real-time service that does run all the time on those back-end systems, so we call that on-access scanning. Essentially, anytime a file is opened or saved, so a file's copied in from FTP, somebody opens and edits a file and saves it, or somebody just tries to open and read a file, the service will actually scan that before control is handed off to the end user. So everything is intercepted in real time, done before anybody gets a chance to actually access that file. We also secondarily support scanning either at the command line, basically call it on demand. So I'm going to go out and say, go out here and scan /home right now. Or people a lot of times will schedule that through a scheduler like a cron service or an enterprise scheduler. Most of the time, we'll see people doing a mix of those two activities. So much like you have on your PC probably right now, you've got a real time, always scanning everything that you do. And then on Sunday night or Saturday night, it lights off a full system scan just to double check everything in the background. Most of the time, we'll see that same type of architecture on our customer systems. They're going to run the real-time scanning service, watching those transactions that come in, especially if there's any kind of file copy checks, transaction activities happening either in or out of the systems. And then at a predetermined interval, weekly or monthly, they're going to run a full system scan and scan everything on that network system and make sure that it all works. How often do recommended updates come out? Because people a lot of times are trying to reverse engineer exploits. So do we have resources updating and sharing information with customers? So we do have a large research and development team. As you saw on that one slide where we have a lot of different security solutions, we not only have teams that work on the malware side of the house, so the antivirus type solutions, and we generally have malware type updates for those every day, sometimes more than once a day, that come out to those systems. You can either choose to download those at your own interval, or we will recommend at least checking every few hours to see if there's anything that changed. Because if something big does get loose on the internet, we're going to try and get that out there as fast as possible to handle those things. We also have regular full threat research teams that are watching traffic from around the internet. Our on-the-wire network appliances looking for advanced threat actors and CC controls and things are deployed globally at many different ISPs and organizations, and that data is coming back to our threat research teams in real time. So we are continually working through those teams and looking for advanced activities, looking for APTs and other threat actors. So we have a very big organization here at Help Systems. We have, I think we're up to now 25 offices worldwide. So we have a lot of different technologies that we deal with. We think we compare very good against other solutions like open source and the speed at which we can get information out to people because we are a commercial vendor. We are partnering with the big names in security solutions, and we have a broad portfolio of things, everything from the back-end monitoring and alerting on the SIM to the front-end threat researchers looking at direct command and control traffic and activities that are happening. It allows us to have a very broad and fully integrated solution on our side. Any other questions? I don't think I see any new ones coming in. You can, of course, always contact us directly with questions, emailing me or emailing just into our support or chat lines here at Help Systems. I would highly encourage people to take a look at the free trials. We not only have trials available of the Linux and Unix antivirus solutions, we have, if you are in an environment where you're not running a SIM or you want to maybe step off to something better than syslog solutions, we just announced actually yesterday our free offering of our SIM solution, PowerTech Event Manager. You can deploy that inside of your environment and use that for fully featured, a limited amount of devices, so monitor those critical systems. Some small businesses, it might be enough to monitor everything that you have, and then have the ability, of course, to step up to larger enterprise-style licensing if you want to later on. We also have that same type of free option with our network monitoring tool, Intermapper, being able to see those devices and traffic flows on your network. Again, it's full-featured and free for a limited amount of devices. So monitor your critical systems with it. And then if you need to step up to a larger licensing on that later, you certainly can do that. All of those are out there and available to you on our helpsystems.com website. So please go ahead and go in there and check us out. And we'd love to work with you in the future. Other than that, since maybe we have one more question coming. Threat research see systems that are being targeted towards Linux to help with calculating ROI on these Linux systems. We do see that. We see systems targeting Linux. Sometimes we see malware activity that's specifically targeting Unix systems and porting back towards Linux. Sometimes it's more regional based. Right now we're seeing actually, for example, a lot of financial-based malware targeting Latin America. There's a pretty big rash of activity happening down there in multiple countries. We see a lot of more targeted attacks also over in APAC region where people are trying to go after research activity, trying to get to that financial type data, or no, I shouldn't say financial, that engineering type data, where they're trying to steal that IP property rather than maybe so much make money on ransomware. They're trying to be much more stealthy in what they're seeing over there. But we do see those targeted attacks happening all over the world. We have a huge database that we are looking at every day with our threat research teams of activity. So we are getting live activity from all over the world all day long. Our backend command and control and DNS detection databases are in the petabytes of information. Some of the largest that we know of privately, used actually by other third parties as well to do some of their research activity. So we think we have a great full feature. Can we run PowerTech antivirus on things like embedded Windows systems like cache registers and other basic solutions? Not on Windows. We like to play in the spaces where we are best at, so we are a Linux, Unix-based solution only. You can run the management console on Windows, but we do not do a detection engine yet on Windows for the on the endpoint malware solution, so running the antivirus malware software. As far as the broader advanced threat detection and hunting solution, that is on the wire, so that is OS and device independent. It's sitting on the network and watching all of the traffic that's happening across the network. That one does everything from Linux to Windows to your smart refrigerator. Anything that has an IP essentially will be processed through that system. And on that solution, we can see everything. So hopefully I answered everybody's questions. If not, of course, feel free to reach out for us. That looks like it was the last question that was coming in. So my email is here on the slide. If you do think of anything after the fact, or you want to just submit something in private, not to the whole group, just feel free to email me. Other than that, thank you very much for attending, everybody, and I'll give you back a few minutes of your day to go enjoy your lunch.